Hello everyone, my name is Afan Putra Pamungkas. You can call me Afan. I'm from Mechanical Department on State Polytechnic of Malang. Today I want to presentation about AC electrical fundamentals, alternating current, circuit theory, and my subject presentation is first three-phase system, second impedance, third is electrical power. Let's begin with capacitor in AC circuit. When a capacitor is connected to an AC source, it exhibits what we call capacitive reactance, denoted as XC. First, capacitor impedance, the flow of AC current through capacitive reactance. Second, and this is crucial, the current leads the voltage by exactly 90 degrees. Third, the reactance is inversely proportional to frequency. Understanding the relationship between frequency and reactance is fundamental. At low frequency, capacitive reactance is high. The capacitor strongly opposes current flow. As frequency increases, the reactance decreases, allowing more current to pass. Similarly, the capacitance value itself affects reactance. A large capacitance value results in low reactance, while a small capacitance value produces high reactance. The key point to remember, capacitive reactance is inversely proportional to both frequency and capacitance. Next is the inductor in AC circuit. Impedance is one of the most important concepts in AC circuit. Denotes impedance denotes Z is the total opposite in current flow in an AC circuit is the combination of resistance R with reactance, either inductive XL or capacitive XG. The basic formula is simply Z equal U divided by 1. And next is complex number. Complex number is to properly analyze AC circuit. We need to use complex number. These mathematical tools allow us to represent both magnitude and phase angle simultaneously. The general form is W equal A plus GB, where A is real number, resistive component, B is imaginary number or reactant component, and the complex number operation is addition. A plus GB plus G plus GD equal A plus G plus G in bracket B plus D close bracket. Subtraction is A plus GB minus C plus GD equal A minus G open bracket A minus G close bracket plus G open bracket B minus D. Multiplication like a regular algebra, where is J square equal minus 1. And the next is impedance with complex number. Now we know the complex number is represented in circuit component. Each component has a specific representation. First is a resistor R is the real number with a 0 degrees angle. It's poorly resistive. And the inductor XL is represent A plus G with a plus 90 degrees degree angle. And the last is the capacitor XC is represent as a minus G with a minus 90 degrees angle. For give the formula for inductive circuit, Z equal R plus G GXR. XL. And the next is for capacitive circuit, Z equal R minus G XL. In a polar form, Z equal the square root of R squared plus X squared angle arctangent of X over R. Next is the resistor-inductor series circuit. When they connect to an AC source, several things happens. Is the characteristic voltage drop across R equal UW in phase with current, and second is voltage drops L equal UPL leads by 90 degrees angle. Total voltage is U equal root of UV square plus UPL square, and the Z is equal root of R square plus XL square. Cos P is R divided by Z, and sin P is XL divided by Z. Resistor, inductor, and parallel circuit. Resistor, inductor, parallel circuit admit a component concept is admit Y reciprocal of impedance E divided by Z. Conductance G, the formula is 1 divided by R, and the susceptance P or PL is 1 divided by XL. Next is AC electrical power. AC electrical power has three types of power. Apparent power S is S equal U times I or VA. Real power or P equal U times I cos P in unit W. Reactive power or Q is U times I times sin P in unit is VAR, and relationship is S square equal P square plus Q square. Power factor or cos P definition is cos P equal P per S equal R per Z. Typical values in incandescent lamps cos P equal 1, and electrical motor cos P equal 0.8 until 0.9. In fluorescent lamp cos P equal 0.5 until 0.7. In welding machine cos P equal 0.3 until 0.5. Low power factor to high current to high losses. Resistor capacitor series in circuit. The characteristic of resistor capacitor circuit is the currentless voltage U. W equal root of UW UW square plus UBC square, and Z equal the root of R square plus XZ square. The formula is S equal S root of P square plus KJ square. Cos P equal UW divided by U. Sin P UPZ divided by U. And next is RLC RLC capacitor. RLC circuit, series circuit. There are two conditions. First is XL is greater than XJ. When the circuit exhibits inductive behavior, the voltage leads the current and the circuit acts like RL circuit overkill. Second, when XC is greater than XL, the circuit exhibits capacitive behavior, the current leads the voltage and the circuit acts like RC circuit overall. The formula becomes total voltage U equal the root of UW square plus UPL per minus UPC square. In the impedance or Z equal the square of roots R square plus XL minus XG square. Next is the LC resonance. Resonance is the fascinating phenomenon that occurs when inductive and capacitive reactance are equal. The resonance condition occurs when XL equals Xc. At this point, the two reactants exactly cancel each other. The resonance frequency is calculated as FR equal 1 divided by 2p times the square root of L times C. There are two types of resonance. Series resonance produce a maximum. First is maximum current, second minimum impedance, ideally just the resistance R. Third is the circuit is purely resistive at resonance. In the parallel resonance produce a minimum current flow and maximum impedance. Next is the three-phase electrical system. Now we move to three-phase system, which is the foundation of power distribution worldwide. Three-phase generator has three stator windings labeled U, V, and W. These windings are physically displaced by 120 degrees around the stator. As winding has terminal U1 until U2 and V1 until V2, and the last is W1 until W2. When the rotor rotates, it generates three AC voltages that are 120 degrees out of phase with each other. This 120 degrees phase difference is fundamental in three-phase system. Include voltage is given by formula Uy equal B times I times V times Z, where B is magnetic flux density, L is conductor length, V is velocity, and Z is the number of conductors. And we move to star connection or Y. In a star connection, terminal U2 and V2 and W2 are connected together, forming the neutral point. The system used for wires is L1, L2, L3, and N for neutral. We have put base to neutral and base to base voltage. The relationship or line voltage equal root 3 times base voltage, line current equal base current, and the looks for the example is if the base to base voltage is 380 voltage, then the base to neutral voltage is 380 divided by root 3, which equal 220 voltage. And the last is delta connection. Delta connection has a characteristic is a apparent power S equal root 3 as Uh, Delta connection has a three characteristics. The first is the winding ends are connected is a closed loop pattern. Second, only three wires are used is L1, L2 and L3. There is no neutral connection. And the last is no path to neutral voltage available. The relationship are exactly opposite to star. First is line voltage equal base voltage, line current root 3 times base current. And the next is the 3-phase power calculation. The general equation are apparent power S equal root 3 times U times L measured in voltage ampere, and the second is real power equal root 3 times U times I times quotient P measured in watts. Reactive power or key equal root 3 times U times L times sin P measured in VARS. The root 3 factor for the 3-phase, let's work through the example with a 3-phase motor. Voltage is 400 volts and current is 8.7 amperes. Power factor is 0.83 and the power equal root 3 times 400 times 8.7 times 0.83, which equally 5 kilowatts. Apparent power S equal root 3 times 400 times 8.7, which equal 6.03 kilovolts ampere. And the next is 3-phase power measurement. Finally, let's discuss how to we measure the 3-phase power in practice. There are three main methods. The one wattmeter method work only balance the total power equal 3 times the reading. This the simplest but less accurate method. For high current we use transformer or CT. A typical CT might have a ratio of 100 to 5, meaning first is primary current up to 90 amperes. Secondary current to the meter is 5 amperes. 3. The primary conductor passes through the CT core. Terminal K and L connect to the bottom meter. And this is concludes of our presentation on AC fundamental. We've covered capacitor, inductor, impedance, complex number, power calculation, resonance, and 3-phase system. This concept form the foundation for understanding AC power system from small electronic circuit to large power distribution network. Thank you for your attention. I'm happy to answer any question you might have, but you can write in comment. Okay, thank you. Bye bye.